alpha. So you're going to have sine of 45 degrees times the cosine of 120 degrees minus cosine of alpha is 45 degrees times sine of beta, which is 120 degrees. Now you just have to use your unit circle, which is on that guide I gave you as well. So you had everything you needed on that guide. All right, the sine of 45 degrees is square root of 2 over 2. The cosine of 120, well, its a reference angle is 60 degrees. So I'm really looking for the cosine of 60 degrees, which is going to be 1/2, but it's going to be negative 1/2 because it's in quadrant 2. Minus cosine of 45 degrees is square root of 2 over 2. And the sine of 120 is a positive square root of 3 over 2. Doing this multiplication, yeah, Gracie. Oh, well, A, it's 120, so it's negative 1/2. But are you asking how I did it in my head? How I was saying it out loud?
I was looking at the side.
Oh, okay.
Thank you.
Because I walked you through using a reference angle.
Yeah.
Because the reference angle of 120 would be 60 degrees. So I'm really only thinking about cosine of 60 degrees, which is 1/2. So that's how I could put it all in the first quadrant.
Okay.
I just need to know it's in quadrant 2 to make sure it's negative. All right, so square root of 2 times negative 1 is a negative square root of 2 over 2 times 2, which is 4. Minus square root of 2 times square root of 3 is square root of 6, all over 4. And that's going to equal negative square root of 2 minus square root of 6, all over 4. Yeah.
I got the right answer, but I had like the cosine of this negative 120 and sine of
Say that again, I'm sorry.
I got the right answer since I had 120 and
You had cosine of negative 120 and sine of negative 120. That would not work out because they're both negative there. Because you would have came out with a negative 1/2 and a negative square root of 3 over 2. That's negative 120. So if you use negative 120 and you got it right, you made a mistake. Well, A, you made a mistake by using negative 120, but you made a double mistake which made it right, I guess. I guess 2 wrongs make a right in this case. But it shouldn't have came out correct. Make sure you don't use negatives. The only time you'd use a negative is if this was like, I don't know, in parentheses, negative 45 minus something. All right, whatever numbers are there automatically puts it in this alpha beta. The negative only affects what's between. That's why I strongly encourage when you're doing these, always keep both those values positive. Like don't ever put a negative 45 minus something. Right, keep those 45 and 120, and then you're fine. Yep. All right, questions on that? All right, we're just going to run through a couple examples to refresh ourselves on how to do these. So first of all, we're supposed to express each of these angles as either addition or subtraction, where alpha and beta are known values on our unit circle. So how can I express 15 degrees, which is not on my unit circle, as two values that are on my unit circle using either addition or subtraction? Liv. 60 degrees minus 45 degrees equals 15 degrees. Another one. Yeah.
45 minus 30.
45 minus 30. Another one. 45 minus 30 degrees. Another one. 130 minus 120.
No, 135.
Oh, okay. I was going to say one. A, it doesn't work, and B, they're not both. Okay. 135. There we go. That fits it. 15. I should have figured it out. So there's multiple ways to do it. And there's multiple times where you might have something different, but at the end, you're going to have the exact same answer. Whatever values I use in the unit circle, these will all work as my alphas and betas. All right, 195. Two values that add together to give me 195, but both of them just happen to be on the unit circle. Yeah.
135 degrees and 60.
135 degrees plus 60 degrees does equal not 135, 195. Good enough, but there's, oh yeah, I'll take another one.
45 degrees plus 150 degrees.
40 degrees plus 150 degrees equals 195 degrees. My advice to finding these aren't really hard ones, but you will find some really hard ones sometimes in the homework or something like a weird negative number. My advice to you is pick an angle. Pick 30 degrees and go, okay, 30 degrees plus what equals 195, and just see if that other angle is on the unit circle. And if that doesn't work, try 45 degrees. 45 plus what equals 195, and then see if it works. That one would work. All right, so what I always do, if I'm really struggling to find the two angles that are on the unit circle, pick any angle, 30, 45, and just see what you have to add or subtract to make that true and figure out if that angle's on the unit circle. Sometimes it's really hard to find both of them, especially when it's a weird, like, negative 75 degrees or something. Sometimes there's weird ones, and just pick one angle and just see if it works with another angle. All right, this next problem is just using an appropriate identity to find the exact value of each expression. Do not use a calculator. So we know that 7 pi over 12 is not on our unit circle. Let me rephrase that. We should know 7 pi over 12 is not on our unit circle, is not one of our major angles. What can I rewrite this as using either addition or subtraction so that it's two angles that are on our unit circle? Yeah?
Pi over 3 plus pi over 4.
Pi over 3 plus pi over 4. Let's do a little scratch work off to the side to make sure it's correct. Pi over 3 in terms of a denominator of 12 would be 4 pi over 12. Pi over 4 would equal 3 pi over 12. I'm going to definitely say that works because that added together would be 7 pi over 12. I had a great question in the other class, and I'm going to bring it up now just in case I don't get the question. How do you know which one to put first? It doesn't matter. Pi over 3 plus pi over 4 is the same thing as pi over 4 plus pi over 3. You do not care which one you call your alpha and which one you call your beta if you are adding. If you're subtracting, there is a definite order that you have to have. But in this case, just pick that first one to be your alpha and pick that second one to be your beta. But if you would have made your beta pi over 3 and your alpha pi over 4, it would have worked out just as fine. All right, cosine. When you're adding angles or subtracting angles, it's going to be cosine, cosine, minus or plus, sine, sine. So cosine is always cosine, cosine, sine, sine. So we are going to have cosine of our alpha, which is pi over 3, times cosine of our beta, which is pi over 4. I'm going to skip the addition or subtraction for right now, just knowing it's cosine, cosine, sine, sine. As opposed to our sine one, which goes sine, cosine, cosine, sine. So cosine is cosine, cosine, sine, sine. You've got to figure out if it's addition or subtraction. The weird thing about cosine is you're adding angles, but this is actually going to be a subtraction sign. All right, now we just need the cosine of pi over 3. What is the cosine of pi over 3? It is 1/2. Cosine of pi over 4, that's the easy one because that's one of those quarter angles. So that's going to be square root of 2 over 2. Minus, well, if cosine is 1/2, then sine must be square root of 3 over 2 times our sine of pi over 4, which is square root of 2 over 2. The good thing about cosine and sine, these aren't really hard to simplify. We're just going to multiply straight across to get 1 times square root of 2, which is square root of 2, over 2 times 2, which is 4. Subtracting square root of 3 times square root of 3 is square root of 6, all over 4, which is going to equal square root of 2 minus square root of 6 over 4. Sine and cosine are pretty easy because it really is just plug and chug. Know the formula or don't know the formula. It's kind of a all or nothing kind of thing there. Tangent's a little tougher. Tangent is a little tougher. So that's our next one. So we're going to plug it in. And a lot of times tangent is the one that requires extra steps because we're going to have fractions over fractions. And we'll have to multiply by the conjugate. So sine and cosine should be the ones on the test you're like, yeah, I'll put a bunch of those on because those are just plug and just simplify a little bit. These are a little harder to simplify. So I have tangent of negative 15 degrees. 15 degrees is not on my unit circle. How, using addition or subtraction, can I represent negative 15 degrees? Yeah?
30 degrees, or tangent of 30 degrees minus 45 degrees.
Yeah, perfect. This is going to equal tangent of 30 minus 45 degrees. This, once again, might be one of those cases where you're like, okay, 30 degrees minus what equals 15, 45? 45 is on my unit circle, so I'm going to use that. All right, now we're going to plug that into our values. Now we're using subtraction. So our first one has to be our alpha. The second one has to be our beta. There's no way to switch these. 45 minus 30 does not equal negative. It has to be in this order, so your first one has to be your alpha. Your second one has to be your beta. Now with tangent, if I'm subtracting angles, you are going to have tangent minus tangent on top. So that's tangent of my alpha minus tangent of my beta. Well, since I'm subtracting on top, I add on the bottom. That's how tangent works. So we're going to have 1 plus tangent times tangent. Tangent alpha times tangent beta. So that's, I probably shouldn't put alpha and beta. I should probably put 30 and 45 in there. That'd make more sense. 30. I just segued into how I kind of remember these. I remember sine as being sine, cosine, cosine, sine. I remember cosine as being cosine, cosine, sine, sine. And I remember tangent is tangent plus or minus tangent all over 1 minus tangent, tangent. So I kind of let the alpha and betas sort themselves out once I have all that stuff memorized. All right, let me remove that beta and actually put a 45 degrees in there. All right. Tangent of 45 degrees, that's the easy one. It's 1. Because remember, tangent is sine over cosine. And sine and cosine are the exact same thing at 45 degrees. So tangent must be 1 there. What is tangent of 30 degrees, though? What is tangent of 30 degrees? Tori? Yep, square root of 3 over 3. So we are going to have square root of 3 over 3 minus 1 all over 1 plus tangent of 30 is square root of 3 over 3. Well, tangent of 45 is just 1, so I'd be multiplying by 1. I guess you could put it on there if you want to. I usually don't put the 1s if I'm multiplying, but it really would be times 1. Doesn't affect anything. It's just multiplying by 1. Here's where tangent kind of is bad. You get a lot of points here. You get a lot of points here because you're doing what I want you to do, but it's not simplified, so you don't get 100% of the credit. You get most of it, but it's not simplified, so you don't get all of it. Now, the easiest way to simplify this is to first get rid of the fractions. This is good here, and it's also good when we prove identities, is getting rid of fractions in the numerator and the denominator. Note, this top fraction has a denominator of 3, and this bottom fraction has the denominator of 3. So the easy way to clear out these fractions is just multiply by 3 over 3. Because I could do that. 3 over 3 is just multiplying by 1. That's okay. And when I distribute this to everything in the numerator, my fraction is going to clear out because that's square root of 3 times 3 over 3, which just leaves us with square root of 3. 3 times 1 is so minus 3 all over, and we do the same thing in the denominator. 3 times 1 is 3 plus 3 times square root of 3 over 3 is just square root of 3. but it's still not simplified. We have a square root in the denominator. And you cannot just multiply the top and bottom by square root of 3. Because if you were to do that, if I multiply the top and bottom, so don't write this, we're just pretending like I'm doing it wrong. If I multiply the top and bottom by square root of 3, this square root of 3 would distribute here, and you'd still have a square root down there. So that's not going to work. So instead, you have to multiply by the conjugate of your denominator. Your conjugate would be 3 minus square root of 3, which means on top I'm going to multiply by 3 minus square root of 3. Well, what I always do is I just distribute. So we have a binomial times a binomial. So I'll take that square root of 3 and multiply it by those two terms. Square root of 3 times 3 is 3 square root of 3. Square root of 3 times a negative square root of 3 is a negative 3. Now we have to distribute that negative 3 to both of them. So I have negative 3 times 3, which is a negative 9. Negative 3 times a negative square root of 3 is a positive 3 square root of 3. All over. Now you could distribute this. You could distribute the denominator just like we did, or you can recognize the fact that it's a plus b. You'll write that below it. It is a plus b times a minus b, which equals a squared minus b squared. So I take that first number, which is 3, and it'd be 3 squared, minus our second term is square root of 3, so it'd be square root of 3 squared. All right, now we just need to simplify stuff. Negative 3 minus 9 is negative 12. 3 square root of 3 plus 3 square root of 3 is a 6 square root of 3. All over 3 squared is 9. Square root of 3 is, or square root of 3 squared is 3, so it'd be 9 minus 3, which is 6. Now we can break this apart into two fractions. Negative 12 over 6 plus 6 square root of 3 over 6. Or what I usually do is I just draw an arrow saying I'm breaking it apart, but I'm not going to draw it. So I'm basically splitting that 6 apart into those two fractions, which is going to leave me with negative 2 plus square root of 3. Awesome if you can get all the way to here. Awesome, you get full points. On the test, if you're struggling to simplify this, don't spend 10 minutes. Most of your points are right here. Most of your points are right here. This is kind of that gravy on top. If you're wasting 10 minutes going from here to here for 1 point on a test, you're probably not taking that test effectively. So if you're really good at simplifying it, take your time, get through it. If you're really bad at simplifying stuff, give it a shot, and if you get stuck, go to a next problem, and then put a little star saying go back to this and see if you simplified it correctly. All right? Otherwise, today is mostly review. On your homework, I do want to point out just a couple things. On 47, 49, 50, 51, it says simplify each expression using appropriate identities. Do not use a calculator. What that means is, if when you're done, it's a value that's on the unit circle, you have to put an answer. So if I said, if it results in sine of pi over 6, you would just say it's 1/2. If it's not on the unit circle, you just leave it. So if your end answer is sine of 7 pi over 11, not a unit circle, just leave it as sine of 7 pi over 11. Go as far as you can without using a calculator. But you should be able to break it down to like sine of something, cosine of something, tangent of something, cosecant of something. If you go one step further, then do it. On 55 through 62, you're using cofunctions. So you can look up cofunctions again, or you can look at that identity sheet I handed out. Yes?
I noticed for 47, you put cosine of negative 87 degrees, then sine of 87 degrees on the other part of it.
What number am I looking at? I'm sorry.
47.
47. Yeah.
Is that, is there both be,
What,
are both 87s supposed to be positive and negative, or is one supposed to?
there's no mistake there,
Okay.
but you can do something.
Uh,
Odd even functions. You're gonna ask yourself, how can I get rid of it? Because it needs to be the same.